All right, in this video's lesson, what we're going to be talking about is the difference between observational studies and experiments. We're also going to talk about some of the key features of both of these studies. We're going to start by discussing the difference between the two. So, beginning with the definition, an observational study is where researchers don't assign choices, they simply observe them. In other words, no treatment is imposed. In an experiment, researchers will assign choices. They will still then observe them, but there is a treatment that's imposed. To give you an example of an observational study, maybe you're interested in what types of trees squirrels prefer to climb or prefer to live in. Well, you can't exactly go and ask a squirrel which tree they like best. And so your best option is probably to just sit out on your front yard or sit out in a park and just watch what trees squirrels choose to climb. You're just observing. You're not assigning any treatments to them. You're not imposing anything on them. You're just observing. There are two types of observational studies. The first is what's called retrospective. In a retrospective study, the study is based on historical data and memories. In other words, you're going back to look at all of the data. Whereas in a prospective study, the subjects are identified in advance and then data is collected as events unfold. So basically, retrospective, you're going back and looking at what's already happened. Prospective, you are identifying who you want to observe and then watching as it happens. So as an example, in early 2007, a larger than usual number of cats and dogs developed kidney failure. Unfortunately, many of them died. Initially, researchers didn't know why, so they used an observational study to investigate. Suppose you were called on to plan a study seeking the cause of this problem. Would your design be retrospective or prospective, and explain? So here's what we want to think about. If we're going to do a retrospective study for this particular example, that would mean going back to see which cats and dogs passed away and why it was that they developed the kidney failure. So we're looking at what's already happened. In a prospective study, we would be identifying cats and dogs that were currently okay and then watching to see if they developed kidney failure and then watching to see what the reason was for it. Now, personally as a pet owner, I can see one of those being much better and probably more ethical anyways, and hopefully you do too. I would say that the retrospective study makes more sense in this case. And again, for the explanation, I won't write this out. I will just talk you through it. But the reason would be that you would rather probably go back and see data based on what's already happened rather than waiting for an unfortunate event like waiting for a cat or dog to pass away instead. All right. So some more definition terms that are going to lead us into our discussion of experiments. First is random assignment. So that's where subjects are assigned to treatment by chance, which was one of our big ideas of sampling. It's also a big idea in experiments and in observational studies. Secondly is a factor. So a factor is a synonym for explanatory variables. And explanatory variables are what explains changes in the response. So you can see kind of the word parts. Explanatory comes from the word explain. So factors are your explanatory variables. They are what you're trying to see has an impact on a response variable, which leads us to the discussion of response variables. And response variables are just the variable that's being measured. So then an experiment is an investigation where the factors are deliberately manipulated to control the details of possible treatments, which are randomly assigned. Probably the best way to think about an experiment is really as a science experiment. And I'm sure everyone's done a science experiment at some point. I remember personally for my 4th grade science project, I wanted to see what type of liquid grass grew best with. And so I ended up picking out 3 different liquids. I picked water, milk, and Gatorade to see which type of liquid the grass would grow best with. And so my random assignment then was I randomly assigned each kind of piece of soil to the different liquids. So one got water, one got the milk, and one got the Gatorade. The factors then were the explanatory variables. In other words, my factors were the different types of liquid that I was using. So one factor was the type of liquid. Then the response variable was the height of the grass. So what I was doing was measuring how well the grass grew with each of those different types of liquids. Now I can tell you that the water worked best, and I can tell you my parents weren't very happy about the milk, especially the milk. The Gatorade was okay, but the milk was pretty bad, especially the smell. They were not happy with me on that one. All right, let's go ahead and continue by looking at this. So our experimental units and subjects are the individuals on whom we experiment. So for me in that science project, my experimental units were the plots of soil with the grass seed. If it ends up being that they are a human, so if our individuals that we're doing our experiment on are humans, we call them subjects rather than experimental units. That's just kind of a, I guess, more nice way of referring to humans as subjects rather than experimental units. Experimental units sounds kind of harsh, kind of removed from the humanity of it. So that's kind of the reason for using those terms differently. The levels then are specific values that the experimenter chooses for a factor. And so in addition to watering the grass with the different types of liquids, I also used different amounts of liquid. So there was one plot that got a little bit of water, one that got a normal amount, and one that got a lot of water. And then I did that same thing for the different liquids as well. So those would be your levels. The treatments then get to be even more specific. So the treatment is your combination of specific levels from all of the different factors. In other words, the treatments would be that one plot of grass got a little bit of water, one got a normal amount, one got a large amount. Then one plot got a little bit of milk, one got a normal amount of milk, and one got a large amount of milk, and so on all the way through the Gatorade. So the treatments are those individual things that happen, the combination of the different levels from all of the different factors that you're considering. So to look at one example, and then that'll be it for this video. In 2007, the deaths of a large number of pets and cats were ultimately traced to a contamination of some brands of pet food. The manufacturer now claims that the food is safe. Before it can be released, it has to be tested. In an experiment to test whether the food is now safe for dogs to eat, what would be the treatments and what would be the response variable? Let's first talk about the treatments. So for treatments, we're going to say that the type of food is definitely going to be a treatment. So obviously one group is probably going to get the new food. The other one would hopefully be getting some kind of a control, some kind of pet food that's already known to be safe. Hopefully they are not trying to compare the new food with the old food, since the old food we've already determined is probably the cause of the problem. They might also choose to measure the amount of food. And so then the treatments would be the combination of the type of food and the amount of food being given to these dogs for this experiment. So then the response variable is whether the food is safe or unsafe. So they're obviously going to be checking to make sure that the dogs develop healthily with the type of food and amount of food that they're being given. Let me make sure I spell response correctly. All right. So at this point, that's all I've got for you with observational studies and experiments. Hopefully you can now determine the difference between the two, as well as identifying kind of all the key features of each of those two different studies. Next time, we will be talking about the 4 principles of experimental design, so making sure that all of our experiments are set up in a way that leads to the results that we want. Until then, have a great rest of your day.